Welcome to Ask and Learn.
The domain for this one is x is all real. The intercepts are 0, 0 is the easy one to see. In addition, we have pi 0. And then we have 2 pi 0. And the pattern continues 3 pi 0, etc. Symmetry is odd. There are no asymptotes. All right, and now let's take a look at increasing and decreasing intervals. So y prime, first derivative test. Y prime is sine squared x over cosine x plus 2 squared plus cosine x over cosine x plus 2 equals 0 to find the critical points. X equals 2 pi over 3 and x equals 4 pi over 3 for every period of 2 pi. Now this is periodic, so obviously it will repeat. Okay, so first derivative test. Let's put 2 pi over 3 here and 4 pi over 3 here. It's going to be increasing here. Between these two values, it will decrease, and then it will increase from then on. All right, and just so we know, f of 2 pi over 3 gives us 0.58, and f of 4 pi over 3 gives us negative 0.58. All right, so this is the first derivative test, which tells us increasing and decreasing intervals. And now we can solve for the second derivative to test for concavity. All right, so y double prime is equal to 2 sine x times sine squared x plus cosine squared x plus cosine x minus 2. And that's all over cosine x plus 2. And that's going to be cubed. All right, so we have x equals 0, x equals pi, and x equals 2 pi for the region that I'm graphing. All right, so here's f double prime for our second derivative test. I have 0, pi, and 2 pi. Here it's going to be concave up. Here it's going to be concave down. Here it's going to be up and go back to down. So just as a reminder, sign switches means these are all inflection points. So inflection point, and inflection point. Now we can graph. All right, so we have no asymptotes, but we do have intercepts at 0, 0. Here's 0, 0. Pi 0. So let's say this is 2 pi. So we know half of that is pi. And here's negative 2 pi. All right. So here we have pi 0 an intercept. So that means at negative pi 0 we'll have an intercept. 2 pi will have an intercept. That means at negative 2 pi will have an intercept. All right, and we know that it's increasing and then decreasing. So an increase and then a decrease means that this is a local maximum value. So let's say that this is 1 and this is negative 1. So we have 2 pi over 3 and 0.58. So that's approximately 2 pi over 3, 0.58. Let's say it's right there. This is just a rough sketch. And then we have our minimum value, 4 pi over 3, 4 pi over 3, and negative 0.58. Let's say this is our minimum value, local minimum. So now it increases, hits our max, decreases, and then it will continue decreasing until it hits our min, and then it will increase again. And then all right, and it's going to do the same thing on the other side because it's odd, but you know, showing odd symmetry. All right, and let's test for concavity. It's going to continue. So concavity, we're going to see it's concave up from before 0, it'll be concave up. That's correct. After 0, 0, it'll be concave down until it hits pi, correct? And then it will be concave up.